Which agent harness is the best agent harness? A objective ranking, right, boys? From start to finish. So objective, meaning we're going to be testing it out, and best determines on what you're trying to use it for. Are you trying to use the harness for long running tasks? Are you trying to use it to code? Are you trying to use it as an assistant? Best is subjective. I like to use my agent harnesses as assistants and coding agents. So that means there's a couple of choices for me. The first is GPT Codex, very good. The second is Opencode, very good. The Honda Civic of agent harnesses, and I mean that with much love. It's a very good harness, right? I take a Honda Civic any day of the week as my means of transportation. Have you ever ridden an e-bike? Well, Pi Agent is the e-bike of agent harnesses, right? It'll get the job done. It'll get you there pretty quickly, but it is very minimal. And sometimes that's all you need. You just need to get there. You don't need to carry a whole bunch of stuff to achieve your goal. Pi Agent is very good for that. So we'll be testing all three of them. Hermes is not included. Hermes is like a rocket ship, and that's not what I want to cover in this video. But I might do a whole dedicated video just to Hermes Agent. Before we get started with the rest of this video, let's do a quick review on what exactly is an agent harness, right? An agent harness is effectively the loop around the model. Think of it as an engine, right? And you want the engine to achieve a goal like fix this Python app. Your harness takes the model and puts it in a loop for it to achieve that goal. So to fix the app, it might inspect files, search the code, edit the code directly, execute commands to verify its edits worked, and then read errors. And then it'll go back and try that entire process again. Why the harness matters is that each harness is effectively its own implementation of an engine, right? So harness A might be a linear harness, do 1, then 2, then 3. Harness B might be a branching harness, right? Its architecture might have it make multiple file edits at once. Whereas harness C might make a small change and then revert back after it tested and validated it, right? Different harnesses basically are different baked in workflows, and this can have a impact on the results that you want to get. Now let's talk about the challenge itself. We're going to have one model and 3 different harnesses build out a black hole simulator. So the challenge is relatively straightforward. We are going to get these 3 agent harnesses installed on our system. The layout of the challenge is going to be straightforward. We're going to have 3 agent harnesses we're going to get installed: Codex, Pi Agent, and Opencode. We are then going to create 3 folders for each one of these agent harnesses right here, here, and here. Inside of each one of these folders is going to be a spec and implementation plan. The model, which is going to be ChatGPT 5.6 Tera, is going to see the exact same spec and implementation plan right here. So they should, in theory, get identical results. We'll be testing that out. The models should also be getting similar amounts of token spend and turnaround time. Our test is going to see which one of these harnesses is better at these various tasks. So here are the rules for the benchmark, right? Both of them are going to be the same model on the same reasoning level with the same spec and implementation plan on the same machine. Those are going to get the exact same prompt. Once started, it is going to be fully autonomous. I am not going to be interceding or stopping or re-steering. We'll see which harness gets you the furthest without you having to re-steer, and which harness costs the most tokens, as well as which harness takes the longest. And here's the prompt we're going to be giving all 3 harnesses. Read spec.md and implementation-plan.md completely. Implement the Python black hole simulator described by those files. Follow the implementation plan in order. Treat each phase's exit criteria as a gate before continuing. Run the relevant tests and do not replace the required, 2D and 3D simulation math. Done in final acceptance. Done is when final acceptance run has been completed. It's been told to not modify the implementation plan or the spec to make the implementation easier. And then it's supposed to document any requirement that it cannot successfully complete. All right. So in our background, we have Codex up top, Opencode in the middle, and Pi at the bottom. They're each contained within, they each have been assigned their own working directory for Pi, Opencode, and Codex. We're now just going to paste in that prompt into each window, and then we'll paste it here and hit enter. Then we'll paste it here and hit enter. Then we'll paste it here and hit enter. And its job is to implement that workspace, right? And we'll just check back in and we'll see what the results were. We'll see if it came up with the exact same solution every time, if it came up with different solutions, and how much token burn it took for it to find its solutions. See you boys in a few minutes. We are back, and something to note is that I had to interrupt all three. Like, I had to stop and come back and check on all three harnesses, so none of them were able to autonomously build this. And they all ran into issues in the same place, which is running tests. But we'll come back to that later. Another update here. It's still building it out, but I did have it use screenshots during its testing. Out of all of them, it looks like Pi has gotten the furthest in building the black hole sim versus if we go here and we go to Opencode output, you can see it's got the black hole rendering, but it's still not complete. And then you compare that to Codex output, and I feel as if we haven't even gotten to the black hole being generated yet. So as far as time to a usable product, Pi Agent is definitely the quickest. Another quick update, Pi is in the lead with it past 78% down here. Codex is actually number 2 with it reporting 78%. And then Opencode so far is the slowest, right? But it is also reporting the least amount of tokens used. So I'd be interested in seeing what the final reports are on these. All right, we're going to let Opencode keep running. We're going to manually re-steer Codex. And then we're going to do the same with Pi. And we'll check back up in another couple minutes. And we are done. So now it is time for us to do some reporting. Next, we're going to generate reports. I've already started this with Pi. We're going to do the same thing with Codex. Copy the run ID, reopen that harness, and then we're just going to tell it to grab that run, and we're going to give it the exact same run report prompt. That way it generates a report.md. And then we're going to go with Opencode up top. Make sure we copy this session ID. Then we got Opencode pulled up. Then after Opencode's pulled up, we can do run is, and then we just paste our prompt again one last time. And we're going to let all three of those run unattended. And then we'll review the reports at the end and go over the various pros and cons of all harnesses. So this is the final report. Unfortunately, apparently both Opencode and Pi Agent, during the run, I did not properly expose context or telemetry data. I didn't get the token spent or the total amount pulled from that run. So that is my fault. I should have implemented this benchmark better. But as far as implementation goes, we had the fastest turnaround from Pi Agent, right? It got us the fastest render out of all of these. Let's see, when we go into output, right? This is Pi's final result, which I rather like. I think that's a good black hole render. But to note, it was also the first to actually give us a response here. You can see all the way back at like 2 p.m. when I first started this benchmark. You know, it was the first one to turn around a result. If we were to go back to Codex, Codex also gave us a black hole render, but not necessarily the best. Let's see here. I don't think it even finished the implementation all the way. It kept asking for user input. So that is a negative side to Codex right there. I have noticed it is a harness where they always ask for approval, which I kind of get, you know, for user safety, but exact same time, very tedious and annoying. And then of course we have Opencode, which is our final implementation, right? And Opencode, according to reports, is the most complete implementation out of all of them. And it gave us this 10 by 24 render, but it's not very zoomed in. But it's not bad. It's not bad at all. From personal usage, I can say Pi had the fastest turnaround time. Opencode tends to have the most consistent results. I'm not sure what type of like validation they baked into it, but I noticed it can go on extended runs. It can kind of go through loops where it has to go past the context window, compress, and automatically continue. And Codex is Codex, right? So which agent harness is the best agent harness? It's Opencode. We'll keep this short and brief. It is Opencode because it's the most consistent. It got the best results. The fastest is Pi agent. Something I noticed about Pi agent, it is a very lightweight agent. It kind of gets out of the model's way and lets it kind of freehand stuff. If you give it a very good model, that minimal agent design, it can be very good. But because it's minimal agent design, you're kind of trusting the model to let you know when the work is done. And depending on your model, you might or might not get good results. Codex, as far as I can tell, it finished the challenge, but not really. I don't necessarily like the output from Codex. Like, this is its final result as its black hole. And the black hole does exist, but it got rendered upside down. And it's pretty low resolution when you zoom in on it, right? Not exactly what I intended, right? And according to the reports, Codex had the most errors out of all these harnesses, right? So I don't know what ChatGPT's got going on with their model and their harness, but if I was using this in production, I definitely want to go with Opencode or Pi agent, right? But Mr. Low Spec, what about Hermes? Hermes is a different beast. That is like a rocket ship of an agent harness, but I'm definitely going to be making videos on it. I've seen people use it. It seems very interesting. Very interesting. All the same, if you enjoy this content, please hit the like button. If you'd like to see more, please subscribe either here on YouTube or on my other socials like TikTok, Instagram, and YouTube Shorts. As always, thank you for watching and stay blessed, boys.